video, I forgot to fill this last line in. So octahedral, square pyramidal, and square planar. Okay, now we're going to do some examples where we try and figure out which ones they are. So if we're going to do ICL4 minus, and so you might pause the video and try and do the Lewis structure and make sure that you know how to do it. But I is going to have 4. So if you've drawn it correctly, and it doesn't matter how you oriented them in space, but if you've drawn it correctly, you should have iodine with 4 chlorines bonded to it. The chlorines should have their octet rule satisfied, but the iodine has an extra 2 pairs of electrons based on the structure here. So the EPG, we look, how many domains does it have? Well, I count 1, 2, 3, 4, 5, 6 domains. 6 domains, I look at my chart, 6 domains is octahedral. So the EPG is octahedral. But the MG, I have to count how many of these are bond pairs and how many are lone pairs. So I have 4 bond pairs, 2 lone pairs. That's this scenario. So the molecular geometry is square planar. Now let's do ICL2 minus. This has 1, 2, 3, 4, 5 domains. Bond, pair, pair, bond, pair. 5 domains. So the EPG for 5 domains, go and check. The EPG for 5 domains is trigonal bipyramidal. But the molecular geometry, we have 2 bond pairs, 3 lone pairs. So we have to go on our chart all the way over here to 3 lone pairs. And we see that for trigonal bipyramidal, that makes it linear. So this one is linear. Turn the page, try a couple more. Put too many dots on that one, I'm so sorry. Okay, I've done that one a couple of times. Okay, this one has resonance structures. We've done that one a few times. Now I want to point out we got double bonds going on here. A double bond counts as a single domain. I like to think of it as there are 2 cars in this garage. There's only one garage over here, only one location for bonds, but there are 2 cars in that garage. So 2 cars in the same garage, but we count garages, not cars. So this is 1, 2, 3 domains. 3 domains for the EPG is trigonal planar. For the MG, since none of these on the central atom are lone pairs, you get the same thing. It's still trigonal planar. Now this one, you may have drawn this and put a single bond here and the lone pair is on the O, and that's not incorrect. That's a way to start. But then if you went and were trying to obey the electroneutrality principle, you would have moved one down here. So you actually get the same shape whether you move the bond in or not. So you would have gotten the right answer whether you put double bond there or not. But to count domains, we go 1, 2, 3, 4, 5. So 5 domains. The EPG is trigonal bipyramidal. And all of these are bonding pairs, so the MG is also trigonal bipyramidal. I might have miscounted. I definitely miscounted. Okay, I miscounted, guys. I'm really sorry. So that one's going to be octahedral instead. And then square pyramidal. Okay, very good. Okay, phosphate ion. This one was from an earlier homework. SO3 was also from an earlier homework. Okay, this one, 1, 2, 3, 4 domains. Double bond counts as a single domain, so the EPG is tetrahedral. The MG also tetrahedral because there are no lone pairs on here. This one, 1, 2, 3, 4 domains, EPG tetrahedral. MG, though, we have one of them is a lone pair, so the MG goes to trigonal pyramidal because it's 3 bond pairs, 1 lone pair. This one, 6 domains, so EPG octahedral. But MG, one of those is a lone pair, so square planar. Excuse me, square pyramidal. Okay, hopefully I got all those correct. I'm sorry for the mistake up here and then having to watch me fix it. The last video will be about polarity, and it'll be coming soon, hopefully tomorrow.